let us discuss about the redox reactions. First of all, what do you mean by a redox reaction? Any reaction in which exchange of electrons take place between the reactants is called redox reaction. Next, say for example, A and B are reacting with each other to give the, let us say, C and D. In this reaction, let us say A has lost the electrons, so like this. A has lost the electrons, so A has been converted into A positively charged ion. So in this reaction, since A has lost the reaction electron, therefore this process is called as the oxidation. Therefore oxidation means any process in which loss of electrons takes place or any process in which de-electronation takes place is called oxidation. Next, if any other species gains the electrons, say for example B is gaining the electron. If B gains the electrons, it gets converted into B minus. Therefore any process in which gaining of electrons takes place or any process in which electronation takes place is called reduction. Next, usually which substances will lose their electrons or which substances will supply their electrons to the others. Say for example, if you observe the oxidation state of the central atoms in various molecules, say for example H2S. In H2S, the oxidation state of the sulfur is -2. Next, similarly in NH3, the oxidation state of the N is -3. Therefore, observe the oxidation state of the central atom in any molecule. If the oxidation state is least possible value, then that entire molecule will always act as the electron supplier, or that entire molecule will always loses its electrons, or that entire molecule will undergo oxidation. Therefore, the basic principle for a molecule to undergo oxidation is the central atom must have the oxidation state value as least as possible. You see here sulfur. For sulfur, least oxidation value is -2. In case of ammonia, the least oxidation state for nitrogen is -3. Therefore, in ammonia, oxidation state is -3. Therefore, ammonia will act as the electron supplier. Next, the electron supplier is also called as the reducing agent. Similarly, observe the water molecule. In water molecule, oxygen is in its least possible oxidation state. Therefore, water can also act as the electron supplier or water can also act as the reducing agent. Similarly, like that, first you select various types of the molecules. Say for example, another example I will give methane. In methane, the oxidation state of the carbon is -4. Therefore, in every molecule, wherever the central atom is in its least possible oxidation state, then that entire molecule will act as the electron supplier or reducing agent. Similarly, in general, which type of molecules will gain the electrons? Say here in this reaction, B is gaining the electron, so it has got converted into B minus. Like that, you observe the various chemical species. Let us say KMnO4. Similarly, let us say N2O5. Similarly, let us say SO3. Like that, you observe the oxidation state of the central atom in various molecules. See here, what is the oxidation state of the manganese? +7. Manganese +7. So this manganese, this +7 is the highest possible value for the manganese. Similarly, nitrogen, what is the oxidation state here? +5. This +5 is the highest possible value for the nitrogen. Similarly, for sulfur, oxidation state is +6. For sulfur, the highest possible value is a +6. Therefore, here it is also exhibiting the +6. Similarly, XeO4, in the xenon tetraoxide, here oxidation state is a +8. Therefore, when we have a set of molecules, first identify the oxidation state of the central atom in every molecule. If that oxidation state is highest possible value, then that entire molecule always act as the electron gainer or oxidizing agent. Here, if the oxidation state of the central atom is least possible value, it will act as the electron supplier or reducing agent. Whereas if any molecule in which central atom exhibits the highest possible oxidation state, then that molecule will gain the electrons or it will act as the oxidizing agent. Based on the nature of the species that participates in the exchange of electrons, the redox reactions are divided into two types. First type, normal redox reactions. Normal redox reactions. Second type, abnormal redox reactions. Abnormal redox reactions. Next, in a normal redox reaction, what actually happens? So here two different species are participating in the reaction. Here A is, that means one species is losing the electrons, the other species is gaining the electrons. That means two different species are exchanging the electrons. That means one is undergoing oxidation, the totally different species is undergoing reduction. Therefore, any reaction in which two different species exchange the electrons is called normal redox reaction. The best example for normal redox reaction is zinc. For zinc is reacting with the copper sulfate. Therefore, here zinc sulfate plus copper. In this reaction, zinc is losing its electrons, hence it has been converted into Zn2+. Zinc is losing its electrons, therefore we can say zinc is undergoing oxidation. Next here, copper is gaining the electrons. See, Cu2+ is getting converted into copper. Therefore, since copper is gaining the electrons, we can say copper is undergoing reduction. It is undergoing reduction. That means in this reaction, totally two different species are undergoing the oxidation and reduction. Next, abnormal redox reactions. So what do you mean by abnormal redox reaction? First, let us observe the one example, simplest example. Chlorine is reacting with the sodium hydroxide and it produces the NaCl plus NaOCl plus H2O. In this reaction, before participation in the reaction, the oxidation state of the each chlorine is 0. Next here, one chlorine atom is getting converted into NaOCl. The another chlorine atom is getting converted into NaCl. Here, one chlorine atom which came here, it is exhibiting the oxidation state +1. The other chlorine which is coming here, it is exhibiting the -1. That means one chlorine is undergoing oxidation. Another chlorine is undergoing reduction. It is undergoing reduction. That means in this reaction, atoms of the same element are undergoing oxidation and reduction. Next, observe the another example. Then we will discuss about the what is meaning of abnormal redox reaction. SO2 plus H2S. Here, S plus H2O. The oxidation state of the sulfur here is +4. Here -2. Here oxidation state is 0. That means here the sulfur, it is changing its oxidation state from +4 to 0. +4 to 0 means it is gaining 4 electrons. Hence we can say it is undergoing reduction. Here in this sulfur, the sulfur, it is changing its oxidation state from -2 to 0. Therefore, it is losing its electrons. We can say it is undergoing oxidation. That means in this reaction, chlorine atoms are undergoing oxidation and reduction. Here sulfur atoms are undergoing oxidation and reduction. That means in both these reactions, the atoms of the same element are undergoing oxidation as well as reduction. Therefore, in any reaction, if the atoms of the same element undergo both oxidation and reduction, then they are called abnormal redox reactions. So therefore, both these reactions are the examples for abnormal redox reactions. But the difference between these two examples is, here before reaction, the oxidation state of every chlorine is 0, but after the reaction, the oxidation state of the chlorine has become +1 and -1. That means the oxidation state is changing from 0 to different oxidation states. But here, before reaction, the oxidation state of the sulfur atoms are different, +4 and -2, but after the reaction, it has been converted into 0. That means here, the difference between these two reactions is 0 oxidation state is getting converted into plus and minus, different oxidation states. Here, different oxidation states are getting converted into 0. Therefore, in both the reactions, same element is undergoing oxidation and reduction, but the difference is in this reaction, the 0 oxidation state is getting converted into different oxidation states. Here, different oxidation states are getting converted into 0 oxidation state. Therefore, in any reaction, If the zero oxidation states converts into different oxidation states, then that is called disproportionation reaction. Disproportionation. This is disproportionation reaction. Whereas if the different oxidation states convert into zero oxidation state, that is called comproportionation. Abnormal redox reactions are two types, disproportionation and comproportionation. In the disproportionation as well as in comproportionation, same element participates in the exchange of electrons, but the difference is zero oxidation states will be converted into different oxidation states. Different oxidation states will be converted into zero. If the zero converts into different oxidation states, that is called disproportionation. If different oxidation states converts into zero, that is called comproportionation. Next, in every redox reaction, how to identify which will undergo oxidation, which will undergo reduction, which will act as the oxidizing agent, which will act as the reducing agent. So first, when a reactant is given, identify the oxidation state of the central atom. For example, KMnO4. Similarly, K2Cr2O7. Similarly, N2O5. Similarly, SO3. Here in all these molecules, first identify the oxidation state of the central atom. Here for manganese +7, for chromium +6, for nitrogen +5, for sulfur +6, similarly XeO4, here oxidation state is +8. In any molecule, if the central atom exhibits the highest possible oxidation state, then that entire molecule will always act as the electron gainer or electron oxidizing agent. It will always act as the oxidizing agent. It will always act as the oxidizing agent, oxidizing. Therefore, based on the oxidation state of the central atom, if that oxidation state happens to be highest possible value, then that can be called as the oxidizing agent. Therefore, all the molecules in which central atom exhibits highest possible oxidation state will always act as the oxidizing agent. Next, second case. Observe the another set of molecules. Here ammonia. The oxidation state of nitrogen is -3. Similarly, H2S. The oxidation state of the sulfur here is -2. Similarly, HCl. The oxidation state of the chlorine is -1. Similarly, methane. The oxidation state of the carbon is -4. So, when we have a set of molecules, first identify the oxidation state of the central atom. If that oxidation state happens to be least possible value, then those molecules will always act as the electron suppliers or reducing agents. These molecules, they will always act as the reducing agents. Next, a third set of molecules. So, for example, observe the hydrogen peroxide. Here, oxidation state of oxygen is -1. Similarly, observe the oxidation state of the sulfur in SO2. Here, oxidation state is +4. Similarly, observe the oxidation state of the nitrogen. Here, +4. That means in any molecule, if the oxidation state of the central atom is neither equal to highest value nor equal to least value, then that molecule will always act as both oxidizing as well as reducing. Here, the oxidation state of oxygen is -1. For oxygen, the least possible value should be -2. Highest possible value should be +6 because it belongs to the oxygen family, 16th group. Therefore, its value must be highest. But here, the oxidation state of the oxygen is neither equal to lowest value nor equal to highest value. Hence, it can act as the both oxidizing and reducing agent. Similarly, sulfur. For sulfur, least possible value should be -2. Highest possible value should be +6. But in SO2, the sulfur is exhibiting +4, which is neither equal to highest nor equal to lowest. Therefore, it can act as the both oxidizing and reducing. Similarly, in NO2 also, least possible value -3, highest possible value is +5. Therefore, here nitrogen can act as both oxidizing and reducing agent. So, therefore, just by observing the oxidation state of the central atom in any molecule, very easily we can identify which can act as the oxidizing agent, which can act as the reducing agent, which can act as both oxidizing and reducing agent.